All right, so let's actually look at a problem that talks about normal distributions. And so again, probability is our area under the curve, and almost all the values are within 3 standard deviations of the mean, and the curve is centered around the mean. So a production line produces bags of sugar. They have a normal distribution, not distribution, with a mean of 1.02. So I'm going to write that down using my correct notation, 1.02, and a standard deviation of 0.03. So find the percent of bags that weigh between 0.99 and 1.05. Well, I can see that if I take my mean and subtract my standard deviation, 1.02 minus 0.03, that's 0.99. If I take my mean and add my standard deviation, I get 1.05. So really this is asking what percent of bags weigh between those. So the probability of being between one standard deviation of the mean, I know, is 68.3% when we talk about 3 significant figures. The percentage of bags that weigh less than 0.96. So I actually want to make a diagram. I'm going to put this information on a diagram to help me. So I've got my mean. Actually, I'm going to draw the curve first because you know my drawing is terrible. So here's my standard deviation curve. Sorry, my normal distribution curve. It should be symmetric. Did I not include a picture for myself? I really should have. All right, let's try again. All right, that's slightly better. So somewhere in the middle is my standard deviation. My middle is my mean, 1.02. And then we had 68% of the values that were 1 standard deviation away, 99, 1.05. If I kept going, I'd get my 95% of values, so that's going to be 1.08. Down this way is 0.96. So I know between these two values, from here over, I know that that is 95 point, let's see what your book says. Your book calls it 95.44. Of course, the whole thing totals 100. So if I do 100 minus 95.44, that's going to give me, so let's do that, 100 minus 95.44. That's 4.56. So I'm going to call that green. So that's this bit and this bit between my graph and the x-axis, which I didn't draw in because I can't draw a straight line. So that those 2 bits are 4.56%. So 4.56 divided by 2 is going to be one of them. So divide by 2, and I get 2.28%. So this bit here, where the bags that are less than 96.96 kilograms, so that's all of these bags this way, that's 2% of them. So I'm going to write it in terms of my probability notation. Probability that my bags are less than 0.96, that's 2.28%, because it's half of what's left over, because the graph is symmetric. So let's use our graph again. Now we want the probability that a bag weighs between 0.99 and 1.08. So 0.99 and 1.08. So let's come do that one with pink maybe. So 0.99 to 1.08. Well, I know that this bit is going to be my 68%. And now I'm adding half of that bit. So if I look up at my graph here, I've got my 68%, 68.26 in the middle, and then 95.54 is this whole thing. Yeah? So if I had to do this on a test, and on a test I think they're going to give you these values. I don't know if they're going to expect you to know them exactly. So we've got now we're adding these three sections. So we've got 68.26, or if we add all three sections, 34.13 plus 34.13 plus 13.59. 81.85%. Or if I'm going to round to three significant figures, 81.9%. So that's what we're thinking about with this first start of normal distribution. Let's go into your book now and do some examples.